look at this Wassce Novdec Bece 2026 predictions and trials. It says the diagrams below represent interatomic bonds. Study the diagrams and answer the questions that follow. Please pay attention. I'll explain. I'm not just going to give you the answers, but explain to you how it is, so that in case you get any relevant questions around it, you can be able to answer. Because it's one major area they never leave out. First of all, you see have diagram A here and diagram B here. Now the question says that identify the interatomic bond in A and B. So the first idea you need to have in mind is the interatomic bonds we have. We actually have 3 interatomic bonds. When we talk of interatomic bonds, we are talking about how atoms, 2 or more atoms, bond or combine chemically to form new substances. And when they are combining to form new substances, they have different ways in which they combine. So these ways they combine are known as interatomic bonds. So the 3 types of the interatomic bonds, the 3 interatomic bonds is what we know as what? Ionic, covalent, and metallic. These are the 3 ways atoms combine to form new substances. Like hydrogen will combine with oxygen, calcium will combine with chlorine to form new substances. They all combine in different ways, either being ionic, covalent, and metallic. Now I'm going to explain to you shortly so that you'll be able to do this particular question for me. Now when we say it is ionic, ionic simply means that they lose or gain electrons. When atoms lose or gain electrons, we call them ionic. And the only way you can be able to identify when the diagram is given it is ionic is whether you are seeing plus or minus on any of the diagram. When you see plus and minus, it tells you that it has loosed. If it's loose, it is plus. If it gains, it's minus. So that should tell you it is ionic. Covalent, you don't see any sign. You also always see something like a Venn diagram. This is how we draw a Venn diagram. 2 circles and they are meeting. That should tell you easily that they are covalent bond. And metallic bond, you normally see them together. Plenty, they are always attached together, and normally see plus plus around it. Meaning that these plus plus are delocalized ions. Ions that do not actually have a place to be. They can flow and go to other atoms. And that is how come conductivity is able to happen in metals, because these free electrons will transfer the electricity, will transfer the heat to all parts of the conductor because of this delocalized ion. So now that we get the simple idea, another way you can be able to identify the ionic bond is that ionic bond occurs between metals and non-metals. That is it. It occurs among metals and non-metals. Covalent occur only among non-metals. That is all. The metallic occur among only metals. So that is one way to make it easy for you to identify. Now let's come to the question. It said identify the interatomic bond in A and B. So looking at A, we have plus here. You can see they have plus here, and the arrow over here telling you that this is going to give away. It is giving, so because it's giving, it is plus. This is also giving to this, so it is plus. That is why you see the plus. So if you are seeing this sign plus there, what type of bond is it? Ionic bond, exactly, because they give out, or another one will also receive. So because of that, diagram A over here becomes what? Ionic bond. So this becomes ionic bond, and diagram B becomes what? Covalent bond, because I told you for them you see something like a Venn diagram. The reason is because in covalent bond they don't donate or receive any electrons, but rather they will share their valence electrons, their outermost electrons. They will share it so that they will all become stable. Why? Because at the last shell is supposed to be, apart from the first shell which is K, which is supposed to be 2, the last shells always have to be 8 to be stable. So this one was not stable, but when they share, when I count here, I'm going to get 1, 2, 3, 4, 5, 6, 7, 8. When I count here, I'm going to get 1, 2, 3, 4, 5, 6, 7, 8. So meaning that they are stable. When this one also gives this 1, electron at the outermost shell, this one electron over here, when it gives it out, there will be no electron here, which will be left with these two. And we know the first shell always take 2, making it stable. When this one also gives this one out, there will be no electron here, which will make it will be left with only 2 here, meaning that it is also stable. And that is why we see these signs here. So this is the ionic bond, and this is the covalent bond, as simply explained. This one donates and receive electrons and occur between metals and non-metals. This one share their outermost electrons, and it only occur among non-metals. Okay, let's move on. B says identify the elements involved in each diagram A and B. So how do you identify the elements involved in diagram A and B? That is a question. How will you be able to identify the elements? That is a big question. Now, in order to be able to identify the elements that are in A and B, take into consideration each of the electronic configuration. We have 3 electronic configuration here. So let's look at diagram A first. I'll pick the first one. So when I pick the first one, count the number of electrons you see there. I can see 1, 2, 3, meaning that it has 3 electrons. And these 3 electrons is equal to the atomic number when it is at its free state, meaning that at this level it has not given out. So it's still 3, 3. So the atomic number 2 will help you to be able to determine the name of that element or atom. So if it has 3 electrons, atomic will also be 3. And when we look at the periodic table, the atomic number for 3 is what? Lithium. Meaning that when we take A, the first element involved here is what? Lithium. Let's look at the next one. The next one, to the same thing, will count 1, 2, 3, 4, 5, 6, 7, 8. I get it. 1, 2, 3, 4, 5, 6, 7, 8. 8. In the atomic number, what is the 8th element? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. I get it. Oxygen. So oxygen is the 8th element, meaning that here it also have what? Oxygen. It also has oxygen. So oxygen is the next element in diagram A. Then let's look over here. When we check over here, it also have 1, 2, 3, and it's the same as this. So meaning that it's the same as the lithium. So this should tell you that there were 2 lithium atoms involved in combining with the oxygen atom over here to make it stable. So that is diagram A for you. That is how you'll be able to identify the element if it is drawn this way. So you are going to do the same procedure over here. In this procedure, because the covalent bond, we'll check first of all. You see here it has been represented with dots, meaning that all the dots you see belongs to this side, and all the stars you see belong to the left hand side. So I'll first take this atom and I'll count 1, 2, 3, 4, 5, 6, 7, 8. So it was 8. And what is the 8? So diagram B, we have what? Oxygen. So let's count the next one, 2, and see. 1, 2, 3, 4, 5, 6, 7, 8. I'm counting the dot ones. That one too is 8, and the same as this. So it's the same as oxygen, meaning that 2 atoms of oxygen combined to form this particular bond over here. So we have been able to identify the elements in A, lithium and oxygen. Then in B, we have oxygen. It is 2 though, but it's the same one, because when we counted it, we had 8 electrons. Yet we have 8 electrons, showing you that it is one particular atom, that is one particular type of atom in 2 different forms that are combining to form this new substance. Okay, so that is how to identify the elements. C, identify the chemical name for the substances. So we are going to look at the chemical name of this particular new substance formed here and a chemical name formed here. So here we realize that 2 lithium atoms combined, right? So 2 lithium atoms combined over here to form this new substance. So because these two lithium atoms combine with oxygen, it will form what's known as what? Lithium what? Oxide. Lithium oxide. But how do we write that lithium oxide? Look over here. You realize that here the lithium one is here. We have lithium also here. What? One is here. So how many lithium atoms were involved here? It was 2 lithium atoms that were involved here. We had 2 lithium atoms. Because the lithium atoms that were involved were 2, we are going to write it this way. So let's see how we write that one. So it becomes L what? I. Are you getting it? So it was the lithium will give this one will give 1, this one will also give 1. So 2 lithium molecules came together, the atoms came together to form. So Li, let me write it well. I want you to see it, so let me write it well. So Li2, to tell you that it was 2 lithium atoms that was used in this particular compound. And how many atoms was used for oxygen? 1. So O. So that's why I write lithium oxide. So this lithium oxide for the new substance that was formed. Good. Let's see for diagram B. Diagram B and C that one to the new substance that is for the chemical name for the substance formed. So here we have already realized that it was oxygen and it was 2 different oxygen atoms, O here. So how many O do we have here? 2. So it means that here it becomes oxygen gas, which is also known as O2, because it was O, oxygen molecules 2 that was combined to form it, and that is how we write it, O2, oxygen gas, and lithium oxide, that is Li2O, because there were 2 lithium atoms that were involved in this particular chemical reaction. Then we look at give 2 properties each of diagram A and B. This is simple. When we look at diagram A over here, the properties mean that the features, the things that makes them possible, and we have already discussed some already. Now, 1, it occurs between metals and non-metals. 2, they lose or donate what? Electrons. 3, they form new substance. I get it. They form new substance. So you talk about whatever that we said here, how it was able to bond, those features that they had which enabled them to bond. That is what you talk about, and that is the few I give. They donate and receive electrons to be stable or to be chemically combined. It involves metals and non-metals combining together. Are you getting it? Then it forms new strong substances. It forms new substances. That is it. Diagram B, it occurs between non-metals. That is their features. It occurs between non-metals. They share their outermost electrons to be stable. They form strong chemical compound. The compound they form is very strong, in such a way that very difficult for you to break. So these are some common properties you can see whenever they ask you these types of questions. So take note of this, and please give key attention to it on whatever that I've said. If you have you want any explanation or anything concerning it, drop on the comment section and I'll make a video for you breaking it down just as I've done, for you to understand and get it easily. Remember, 2026 Wassce Novdec Bece, you are going to pass it easily with arguments. Thank you. Bye bye. We shall meet again.